All right, nerds, let's go over some of these things. Let's look at this first. Circle your reactants, put a box around your products, okay? Everything over here, okay? These are, what are they? Our reactants. These are our products, okay? You don't know that? Summer school starts this summer. It's going to be great. We'll have a great time, okay? 2 nitrogens, 1 nitrogen, 2 hydrogens, 3 hydrogens. We need to balance this. Let's put a 2 here. 3 times 2 is 6. 2 here. 3 times 2 is 6. 2 nitrogens, 2 nitrogens. Bam. Okay. Let's look at our next one. 2 hydrogens, 2 oxygens. Only 1 oxygen. Don't put a 1 here, because that is already 1. No number here means you have 1 water molecule. First number we start out with is a dose. 2 oxygens, 2 times 2 is 4 hydrogens. 2 times 2 is 4 hydrogens. Balanced. 1, 2, 2, 5. That's a problem. There's nothing here we can do to times it to get it up to 5. Let's make this all even. We now have 4. 2 times 5 is 10. 5 times 2 is 10. Balanced. 1 oxygen, 2 oxygens. 2 times 2 is 4. 4. All right, ooh, we got parentheses. Exciting stuff. 1 aluminum, 2 aluminum. I'm going to ignore oxygens because they're everywhere. I have 1 SO4, or 1 sulfur. I have 3 SO4s, which would be 3 sulfurs and 12 oxygens. So let's put a 3 here. I now have 6 hydrogens, 3 sulfurs, 12 oxygens. So let's take a look here. 3 times 2 is 6. 3 times 2 is 6. There are 12 hydrogens. 6 times 2 is 12. And last we have is just our oxygens. I say that for last because it's oxygen, 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 oxygen. It's in every single part, making it difficult. 2 times 3 is 6. 3 times 4 is 12. There are 18 oxygens on the left side of our arrow. 4 times 3 is 12, plus our 6. There are 18 oxygens. We're now balanced. 2 irons, 1 iron. 1 potassium, 2 potassiums. Okay. 3 SO4s, 1 SO4. Let's put a 3 here. By doing so, we now have 3 times 2 is 6 potassiums. Oh no, I have to erase something. The world is over. I need a new sheet. And at this point, we're probably balanced. Hydrogens, 3 times 2 is 6. 6. If we go back, we have 12 oxygens plus 6 is 18. 4 times 3 is 12, plus 2 times 3 is 6. That's 18 as well. Balanced. Number 2, technically none of these answers are right. The chemical equation is balanced when coefficients of the reactions equal the coefficients of the products. That's not right. 3 plus 1 would be 4. There's only 2 on this side. This is balanced. A is wrong. B, there's an equal amount of reactants and products. It depends on how you're interpreting that sentence. If what we're saying is we have 4 hydrogens, 2 oxygens, 2 oxygens, that's correct. If we're saying that we have 2 reactants and 1 products, then it would be wrong. Okay? C, products and the reactants are always the same chemical. No, they're not. They're different. D, subscripts of the reactants equal the subscripts of the products. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. This one right here proves that we're wrong. We have a subscript of 3, and over here we have subscripts of 4. No, D's not right. Okay? B is correct only if you're talking about each element. So just to clarify, every reactant has to be the same as your product on either side for every element. Okay? So if we look back at this one, you have the same amount of aluminums, oxygens, hydrogens, sulfurs on this side as you do as your product side. Okay? B is the only answer that makes sense. Balancing. Coefficients are missing. I think I went over this in class. 2 irons. We need 2 irons here. 2 hydrogens, 2 hydrogens. 3 oxygens, 1 oxygen. Let's put a 3 here. Okay. 3 times 2 is now 6. If we do that, we need a 3 here. And I think we're good. If we don't put a number, it means 1. 1, 3, 2, 3. D. Rewrite the following equations. C6H12O6. Sugar. Oxygen is one of our diatomics, plus O dose. We're going to make some carbon dioxide and some water. CO2 and H2O. Straighten that out for you. All right, let's go ahead and get started. 6 carbons, 1 carbon. 12 hydrogens, 2 hydrogens. 6 oxygens, plus our 2 is 8 on this side. And over here we have 6 times 2 is 12, plus our 6 is 18. We need to get 18 over here. Okay? If we take this guy and multiply it by 5 times 2 would be 10, plus our 6 is 16, not enough. Let's try 6. 6 times 2 is 12, plus 6 is 18, balanced. Aluminum, not a diatomic, does not get a number, plus oxygen gas, O2, makes aluminum oxide. This is our ionic formula. We have to look up the charges. You're going to find them on the back of your periodic table. And if we look, we'll find aluminum in the +3 category, and you'll find oxygen in the -2 category. Oxygen by itself is a diatomic. That means if it's by itself, it gets a 2. When you're doing formulas, we have to crisscross. +3, -2. 2, 3. And now we balance. 2, oh, I got 3 here. Let's put a large 2 here. 2 times 3 is 6. 2 times 3 is 6. 2 times 2 is 4. 4. Balanced equation. Barium chloride. BaCl. Ionic. We have a cation and an anion. So I gotta look up our charges. Barium is +2. Chloride is -1. Crisscross. BaCl2. Plus sodium sulfate. Let's look at our list. Double check. Sulfate, SO4. Sodium, +1. So I need Na2SO4. That's crisscrossed. I'm now going to make barium sulfate. We already looked up a charge of +1, -1. BaSO4 plus sodium chloride, NaCl, salt. So now let's take a look. 2 chlorines, 1 chlorine. Let's put a 2 here. 2 sodiums, 2 sodiums. 1 sulfur, 1 sulfur. 4 oxygens, 4 oxygens. 1 barium, 1 barium. Balanced. Magnesium, Mg, plus nitrogen. Let's see. Is nitrogen a diatomic? Oh, why, yes it is. Because we all, not that one, circled are 7 diatomics on your periodic table. You have them circled anytime. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromide, or iodine are by themselves. We give them a little 2. Okay? They're diatomic. Magnesium plus our nitrogen will make magnesium nitride. Now, once again, magnesium charge, boom, is +2. Nitride, right here, is -3. Positive dou, -3. Crisscross, Mg3, N2. Okay? Now that all our subscripts are correct, now we go back and write our coefficients in. Okay? So 2 nitrogens, 2 nitrogens, 3 magnesiums, 3 magnesiums. Balanced. Number 9, what's the balanced formula equation for the reaction shown above? Okay? Just so you guys know, this picture is technically drawn incorrectly. Okay, I'll explain why in a minute. We're going to write our formula for what this picture is, though. Okay, so we have HCl, hydrochloric acid. We're adding magnesium. And we're making magnesium chloride. Okay, and hydrogen gas. H2. Okay. The reason this is incorrect, if we look up the charge of magnesium, this is positive 2, chlorine's negative 1. It should say MgCl2. Okay. That's not in our picture though, so we're going to keep it incorrect. We keep it matching this guy here, right? Because we should still be able to balance this. 2 hydrogens, 2 hydrogens, 2 chlorines, 2 magnesiums. 2, 2, 2, 1. Okay? Based on our picture, that's what we have. What type of reaction is shown in this picture? Hydrogen's dating chlorine. They've been going out for a while. But then magnesium came along and stole hydrogen's girlfriend. Hydrogen is now single and ready to go out on the town. All by themselves, all by themselves. Couple, couple. Because you have someone not with somebody else, this would be a single replacement reaction. Okay? If you're looking for a double replacement, everybody has a partner. Okay? So if we go back up here, barium's dating chlorine, sodium is dating sulfate. Everyone's got a partner, and they switch at the end, double replacement. Okay? If we're looking for synthesis, synthesis means we're going to have things that are by themselves that they can place together, like in D. Magnesium and nitrate are by themselves, and we make magnesium nitride. If we're looking for decomposition, we'll have one substance that breaks down into several other things. If we're looking for combustion, we always add oxygen, okay? And we end up always making CO2 gas and water. So equation A would be an example of a decomp. 7 diatomic elements. They're right here. We just circled them. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. Circle those on your periodic table if you haven't. In the following 5 equations, what would form the 2 reactants? What type are they? Flippity flop. Sodium is by itself, has a charge of positive 1. Iron, bromide. Iron has a charge of positive 3. We know that because of the subscript. And bromide has a charge of negative 1. This is going to be a single replacement. Someone's by themselves. Sodium is going to come in and replace iron. Sodium, positive, wants to stick with our negative. Okay, so this will end up forming NaBr, positive 1, negative 1, plus iron. Okay, to go back and balance it, we need a large 3. 3 bromides, 3 sodium bromides, 3 sodiums. This is a single replacement. Let's look at our next one. Sodium hydroxide. We know that's a base now. Is being paired up with hydrogen sulfate, which is sulfuric acid. Let's see here. Sodium is going to be paired up with SO4. SO4 has a charge of negative 2. So Na2SO4. We're going to add that with H2OH. Okay. Now we're not going to have 3 H's there. Anytime hydroxide pairs up with hydrogen, we're simply going to make water, H2O. Now we simply have to go back and balance. 1 sodium, 2 sodiums. Let's look at our sulfurs. 1 sulfur, 1 sulfur. Over here we have 6 oxygens. Over here we have 5 oxygens. So let's put a 2 here. 2 times 2 is 4. 2 oxygens is 2. 2 here. We're going to end up putting a 2 here. And 2 sulfurs. 2 sulfurs. 2. This is wrong. So what we end up having also, this is impossible to balance, which means I'm missing something. Add hydrogen gas to this. Plus H2. Okay, and by doing so, we're going to erase all these things and start over. And that's fine, because sometimes you have to do that. 2 sodiums, 1 sodium. Put my 2 back. We now have 1 SO4, 1 SO4. I have 2 hydrogens. Over here I have 4 hydrogens and 1 oxygen. Okay, so I'm going to put a 2 here. And now we have 6 oxygens. We have 1, 2, 3, 4, 5, 6 oxygens. We have our 2 hydrogens. We have too many hydrogens. Oh, forgetting about this one. 2 hydrogens here, 2 hydrogens here, 2 hydrogens, 2 hydrogens. We're now balanced. Okay? Sorry about that. Large 2 here, large 2 in front of our water. Okay? 2 hydrogens are here, 2 hydrogens are gas. We have 4 hydrogens, 2 here, 2 here. And I forgot about those 2 the first time. That's why it's such a difficult time balancing it. Right now, we had sodium pair up with sulfate, OH pair up with hydrogen. Okay, so this would be technically a double replacement. Let's look at our next one. C2H4O2, we have a sugar. We're adding oxygen gas. Every time we do this, we're always making CO2 and water. Two carbons, 2 carbons. 4 hydrogens, 2 times 2 would be 4 hydrogens. We have 2 times 2 is 4 oxygens plus our 2 oxygens. So we have 6 over here. 2 oxygens plus 2 is 4. Large 2 here. 2 times 2 is 4 plus our 2. We now have 6 oxygens. Okay, this is combustion. NH3 plus H2O. Right here, for adding water or something, this is going to be an acid-base reaction. Okay, one of these is going to be our acid. One of them will be our base. One of them is going to be our conjugate acid. One of them will be our conjugate base. Okay, looking at these two, right now, NH3, we can always add an extra hydrogen to it. We can make NH4. Okay, ammonia can always become ammonium. That hydrogen had to come off of water. So we take off one H, we're left with OH. Okay, and these always just balance themselves. So we have one nitrogen, 5 hydrogens, and our 1 oxygen. Okay, if we're labeling it our acid bases, right now this has the extra hydrogen. This is our conjugate acid. This is our base. If we look here, comparing our water and our hydroxide, this has the extra hydrogen. That's our acid. It donated it, making this our conjugate base. Acids can always donate a hydrogen. Bases can always accept a hydrogen. Last one, we have lead sulfate plus silver nitrate. Okay. Lead's positive, sulfate's negative, silver's positive, nitrate's negative. We're going to make lead nitrate. We're also going to make silver sulfate. Lead, Pb, looking at our periodic table, has a charge of, let's see here, where's our sulfate? SO4, positive 2, negative 2. That's why we have a 1-to-1 ratio. We have silver and we have nitrate. NO3 has a charge of negative 1. Silver has a charge of positive 1. Okay, 1-to-1 ratio. Over here, we paired up positive 2 with negative NO3. So we need parentheses with our 2. And silver sulfate. Positive 1, negative 2. We need 2 here. To balance it, all we need is a 2 here. Dating, 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 dating. Double replacement reaction. Boom. That's part 1 of your study guide. Good luck on your final.